Hello friends, we are in LV room. LV by LV I means low volts. Low volts in this case it is around 400 volts. If we are dealing with 11 kV, in that case it is high tension, high volts. But in our case this one is low volts. You can see we have two main distribution boards here. MDB2 and MDB1. But now we have an issue here with our power factor, because this was for MDB1. For MDB1 already 9 steps, capacitors are all engaged, but we are not attaining the required. We are not attaining the required. Our target is almost 0.99. Yeah, at times it can indicate unity, but unity is not practical. That is in theory. Yeah? So it has engaged 9. But still we are not attaining 0.99. This one for MDB1, the same case applies for this one MDB2 Capacitor Bank. You can see all of them are engaged, the 9 capacitors, but still we are not attaining what we require. We require at least 0.98 or 0.99, but in this case you can see it is 0.59, which is very low. Yeah. So if you divide the kW divided by the kVA, this is what we are getting. So there's a lot of loss. We need to add capacitors in order to attain that difference of 0.99 kVAR. The kVAR, you know, it is the reactive power. The kW, you know, it is the useful power or the real power. The kVA is the generated power. In other words, what we are getting from, in this case is due by what we are getting from the utility company is the kVA. We use the kW, but you see our kVAR is more. We're getting a lot of loss. There must be a lot of loss, power loss. So all we need is to either to upgrade the capacitors. We can upgrade the steps of the capacitors. Oh, the steps are up to 12 steps. In that case, we can add more capacitors. Yeah. So the capacitor is 300 kVAR. The same case applies to this one, 300 kVAR. So we can do some addition of the capacitors, or we upgrade by replacing the existing ones. Showing undercompensated. It has not attained what we require. It is undercompensated. And it is inductive. You can see it is inductive. If it is overcompensated, either the system can be capacitive, or maybe the capacitors have over-engaged. If it is capacitive, it is indicating CAP, that is capacitive. Either the system can be capacitive, or the capacitors have over-engaged. But you can see now all our capacitors, 9 steps, they are engaged, but it is still indicating undercompensated. Yeah. So in this case, we need to upgrade by either upgrading each step of the capacitors. In this case, each step here, if we divide that one, the 100 kVR, we divide by 9. So if we divide by 9,